Hello everyone, in this video we are going to be discussing VLANs. This video will discuss what VLANs are, how they work, the types of VLANs that are commonly used in industry, and the benefits of implementing VLANs into a network. What are VLANs? VLAN stands for Virtual LAN or Virtual Local Area Network. Essentially, VLANs are a way to connect multiple devices together to form a logical network without having to be physically connected directly to each other. VLANs are a layer 2 technology, meaning that routing is not necessary to send traffic to its destination. Due to the nature of VLANs, two different VLANs will not be able to communicate with each other without routing in place. How do VLANs work? There are two main types of VLAN systems, port-based and tag-based. Port-based VLANs operate by assigning a VLAN ID or VLAN number to a specific physical port on a network. In the graphic shown below, you can see that this is used to allow PC A-1 to communicate specifically with PC A-2. This is the ideal use for port-based VLANs. Tag-based VLANs work by attaching data to incoming packets that contain information about the packet's VLAN designation, more specifically the VLAN ID or VLAN number. That data is then sent through other network devices using trunks until the data reaches its destination. Tag-based VLANs allow network devices to use the same port to send data from multiple VLANs. Types of VLANs. There are many types of VLANs that are in use today. These include management VLANs, data VLANs, voice VLANs, default VLANs, and native VLANs. Management VLANs are essentially VLANs that only carry traffic from devices that are used to manage your network. This may include network monitoring tools, logging tools, Active Directory services, and many other network services. It is important to keep this data separated from the rest of your network because it may contain sensitive information about your network, and it also will reduce the amount of traffic going through other parts of your network. Data VLANs are VLANs that are used to send data generated by users. This is typically the primary VLAN that most user computers and equipment are assigned to. Voice VLANs are VLANs dedicated to sending voice traffic. Due to the nature of voice traffic, it is important that it has access to a high bandwidth across an uncongested line so that the risk of packet loss, latency, and jitter can be minimized. We accomplish this goal by designating voice traffic to its own VLAN so that it is the only data that flows through the VLAN. The default VLAN is basically the VLAN that network equipment defaults to using when ports are enabled. This default VLAN is usually VLAN 1. Due to security concerns, it is important to make sure that the default VLAN on any equipment capable of recognizing VLANs is changed to a different VLAN number, as generally the default port is also assigned to ports that are active but not in use. Native VLANs are VLANs that send untagged traffic through a network. Untagged traffic is usually generated by legacy equipment or equipment that does not support VLAN tagging. Native VLANs allow untagged data to still flow through the network. What are trunks? Trunks are essentially the physical point-to-point connection between two network devices. Trunks serve the purpose of forwarding data from different VLANs across a network through singular physical links, as shown in the graphic below. When data enters the network, it is padded or encapsulated with additional data that usually consists of the VLAN ID or the VLAN number that the data originates from. Once the data reaches its exit from the network, that data is removed and the packet is de-encapsulated. What are access ports? Access ports are logical interfaces that accept VLAN data and forwards data from a specific VLAN to its destination. This would typically be where the decapsulation would occur. Access ports can only have one VLAN assigned to them. For example, if a switch has an access port assigned to VLAN 20 and the network has data flowing through it including data from VLAN 5, 10, and 20, an access port will only accept data coming from VLAN 20. Any other data will be dropped. This is the opposite of a trunk port. Access ports operate this way because they are only intended to forward data to its destination instead of through the network. The benefits of VLANs. There are many benefits of VLANs. VLANs improve your network security by separating users to their own networks. This helps to mitigate network penetration by controlling access on a network level. That said, VLANs should not be your only source of security. because it is not bulletproof. Attackers can still connect to physical ports on a switch and gain unauthorized access if the network is not properly secured. Another benefit of VLANs is that network administration becomes easier. With VLANs, you are able to group ports, users, and equipment to individual networks. This makes it easier to manage network policies and track user activity and data. Additionally, once VLANs are configured, it is easier to make changes in the event of a physical network change, like a PC moving to another office or a new machine being introduced to the network. VLANs are also capable of increasing the quality of your network. Because VLANs split the network up into smaller, isolated networks, broadcast domains also become split up and isolated. When traffic flows through a VLAN, it will only search through its VLAN for the destination instead of sending that data through the network to look for its destination. This decreases the overall load of traffic across your entire network by restricting that flow to individual VLANs. In the next video, we are going to set up a packet tracer, and we will go through the process of setting up VLANs on a simple network. I will also include the starter packet tracer file and a completed solution file so that you can view the source and our end goal and work along with me while we do it. Thank you.